Today, I'm gonna talk about projectile motion. We have a cannon. This cannon will apply a projectile, so we need to figure out the properties of this projectile. Properties means how long, what is the horizontal distance, what is the time, what is the horizontal distance, what is the vertical distance, probably. So we need to learn everything about the projectile motion or about the properties of the projectile motion. But before, I would like to watch this video. So we have a cannon, probably in commerce, and we are fighting another city. So we have a projectile will be thrown on another place. So we need to figure out where the new location of this projectile, how long it will take to reach the desired destination. So all of this stuff, we need to figure them out. As you see, the projectile will take a parabolic path to reach the destination. If we assume at the beginning of the projectile motion, if we assumed horizontal axis x and vertical axis y, we have here initial velocity. Just after coming out from the cannon, we have something called initial velocity, V naught. This initial velocity has inclined angle, theta, with the horizontal. That means we will have two components of the velocity. Horizontal component, Vx, and the vertical component, Vy. So one more time. We have a projectile. This projectile will take a parabolic path. If we assume at the start point, we have origin, we have x-axis and y-axis, that means at the time of release, we have initial velocity. This initial velocity is tangent to the parabolic base. So we have angle here, theta. This angle will help you to break this velocity to two components, horizontal component and vertical component. What is the value of the vertical component of velocity? What is the value of the horizontal component based on this angle, cosine and sine? The component adjacent to your angle is cosine. The component far away from the angle is sine. So Vy will be V sine, Vx will be V cosine. Then we can set up new equations to figure out where is the position x and the position y using these equations. And can you watch these equations? We have a new term, time. T. T is a time in second or minute or hour, the time needed for this projectile from this position to the desired destination. How long it will take for this projectile to reach to the second location. Okay, so the idea in this topic, we have a cannon and we have a projectile taking a parabolic path. At the beginning of this motion, at this location, we have x-axis and y-axis. At the first time of release, we have here initial velocity v naught with inclined angle theta or alpha. I don't care about the name, but we have inclined angle. So this velocity can be broken to two components, horizontal velocity and vertical velocity. It's not horizontal and vertical velocity, but horizontal component and vertical component. Using these components will help you to figure out the horizontal distance x, the time needed for this projectile to reach from this position to this position, then we can figure out the properties of motion. It's very easy. So the equation for common projectile motion may be obtained from the constant acceleration equation. The horizontal component of acceleration is 0. The vertical component of acceleration is negative gravity of acceleration. Negative g means negative 9.81 meter per second square. Guys, by the way, for your information, if you are talking about SI unit, which means meter, kilometer, so G equal 9.81 meter per second square. If you are talking about US unit, feet, pound, all of this stuff, G equal 32.2 feet per second square. Just for your information. But I believe most of our problem will be under these units, SI unit, but just for your information. So we don't have horizontal component for acceleration, but we have vertical component of acceleration equal negative g. The horizontal component of velocity, as I told you, we have initial velocity v naught, we have angle theta of inclination, so the horizontal component will be v cosine. So the horizontal component of velocity will be v naught cosine theta. The vertical component of velocity will be v naught sine theta, v naught sine theta, plus another term due to the effect of gravity equal negative gt. So we have an equation for horizontal velocity, another equation for vertical velocity components. Once you get the horizontal and the vertical component of velocity, we have another equation for how far the horizontal distance between the initial location and the final destination, x. And also y can give you what is the vertical distance for the projectile at any time. For example, at this location, I can figure out how was the height of this projectile at this destination. So x and y equation can give you the coordinates of the projectile at any time. At any time T. These equations will help you to figure out the properties of the projectile, the motion. Any questions so far? Do you have any questions so far? Okay, let me start with first example. We have a projectile has an initial velocity of 85 meters per second and a launch angle of 60. So this projectile will start with initial velocity v naught equal 85 meter per second and an angle of 60. So this angle equal 60 from the horizontal. The surrounding terrain is level. The ground surface is leveled. That makes sense. Ground surface is level means we have horizontal ground surface, because guys, make sure sometimes you have a cannon, you are in the army, we have a cannon, probably this projectile can reach this level or this mountain. So we are talking about two different levels. But in our problem, the problem said this projectile with initial velocity and angle theta, and the surrounding terrain is level. We are talking about horizontal level of the Earth's surface. Anyway, and air friction to be disregarded. What is most nearly the horizontal distance traveled by the projectile? This projectile will travel in a parabolic path until hitting the ground surface. Can you tell me what is the most nearly the horizontal distance? What is the horizontal distance? X. With this initial velocity and initial angle. So let's start. What is the first step? If you are looking for horizontal distance, we are looking for this equation. X equal V naught cosine theta times T plus X naught. Guys, I told you before, any term with naught means initial. Initial velocity, initial acceleration, initial distance, all of this stuff. We have a big issue here. Do you know what is the time t? Do you know what is the time t? No, we don't know. We don't know what is the time t required for this projectile to reach the destination. So we have a big issue here. How can we solve this issue? Okay, I would like to explain it. I will assume wait, this color. I will assume we have origin here, so we have x-axis and we have y-axis. Can you see y equation equal negative g t square divide 2 plus v naught sine theta t plus y naught. We don't have initial y. at the final destination here. Final destination. What is the value at the final destination? What is the value of y? Anybody can tell me what is the y coordinate of this location? Any answer? Thank you. 0. So at this location, y equals 0, equal negative 9.81 g t square divide 2 plus v naught, the initial velocity 85, sine angle 60, time t, the initial y, we don't have initial y, 0. We can simplify this equation to be 0 equal negative 9.81 divided 2, it will be 4.905 t square plus 85 times sine 60. This term will be 73.6 t. If you take t outside, so we have negative 4.905 t plus 73.6. So this equation has two solutions, t equals 0 or t equal 15 seconds. I believe this projectile to reach from this location to the final destination, I believe time cannot be 0. So this solution is rejected. So the required time will be 15 seconds. But the problem did not ask for the required time. We are looking for what is the horizontal distance. Okay. I figured out the required time to help me to use the horizontal distance equation. We have an equation here for x equal v naught cosine theta time t plus x naught. V naught equal 85 cosine 60 time t equal 15 seconds plus x naught, we don't have initial horizontal distance. So your final value for horizontal distance will be 637.5 meters. So guys, if you used a cannon to apply a projectile with initial velocity 85 meters per second and inclined angle 60 degrees, believe me, this projectile will reach the final destination in 15 seconds, and the final destination will be 637.5 meters far away from the initial position. So what do you think? It's very easy. Just keep these equations in your mind. I believe most of the problems will be started with this equation. Why? Why most of the problems will be given 0 or something else. So from this equation, I can figure out the required time. Once you get the required time, I can use the equation for x to figure out the horizontal distance. Let's do another example. But do you have any question for this example? Do you have any question for this example? Okay, one more example. We have a projectile has an initial velocity equal 80 meter per second and a launch angle of this angle of inclination equal 42 degree from the horizontal. The surrounding terrain is level. This information is very important because from this information I can figure out the final value of y. So the surrounding terrain is level. So that means this projectile will take a parabolic base until hitting the ground surface here. If you put at this location x-axis and y-axis, believe me, at this location y equals 0. Anyway, the air friction is to be disregarded. What is most nearly? The maximum elevation achieved by the projectile. What is the maximum here? Maximum height. What is the maximum height? What do you think? Which equation we are going to use? Any help? We are looking for the maximum height. So I believe the first step we need to figure out time, because if you are looking for maximum height, I'm looking for y, how much at this location or at this time, probably. So remember, we can use this equation y, what is the value of y, but we need to figure out what is the time at this location. To figure out the time, what should I do? If you put y equals 0, you can say the time for the final destination, but I'm not looking for the time for final destination. I'm looking for what is the time at this location. Any answer? Okay, so I would like to explain it for you. Guys, I told you any projectile will have an initial velocity v naught, and this projectile will have a parabolic base. Do you agree? Guys, what is the meaning of initial velocity? Mathematically, the initial velocity is a tangent to this parabolic base. Anybody can draw a tangent at the highest point. If you are looking for highest point on a parabolic base, what is the direction of this tangent? Any answer? If you go back to any mathematics course, what is the tangent direction of the tangent of the highest point on a parabola? Thank you, guys. Perfect. Horizontal. Do you think there is a way to get a vertical tangent? No way. The highest point will give you a horizontal tangent. So velocity at this location will be horizontal. That means any vertical component for the velocity will be 0. All velocity will be horizontal. We have a value for horizontal velocity, but for vertical velocity, no, we don't have vertical component. Why? Because the velocity must be tangent to the parabola. At the highest point, the tangent will be horizontal. Horizontal means we don't have vertical component. So I can say at the highest point, Vy equals 0. So here is the equation for Vy. Vy equal negative gt plus V naught sine theta, I think. Negative plus V naught sine theta, yes. Okay, this equation equals 0. Negative 9.81 t plus V naught, initial velocity 80, sine angle 42. The only unknown in this equation is the time. So the time required for this projectile to reach the highest point will be 5.45 seconds. Time required for this projectile to reach the highest point. You cannot solve this example without this information. If you reach the highest point of this parabolic base, the highest point, we don't have vertical component for velocity. So the equation for Vy will be equated to 0. Then I can figure out the required time. Finally, we have equation for y. Negative g t squared divided 2 plus V naught, I think, V naught sine theta times t plus y naught. Go ahead and put your numbers. G 9.81, t, the required time to reach the highest point will be 5.45 seconds. V naught 80, theta 42, time 5.45. We don't have initial y. That means I can figure out the value of y. Y will be 80 times sine 42 times 5.45 minus 9.81 times 5.45 square 9.5. This value will be 146.1 meter. So the highest point will occur at time equal 5.45 seconds. And the highest point will have a vertical distance y equal 146.1 meter. So the most nearly, the maximum elevation achieved by the projectile will be 146.1 meter. The key to solve this example is this information. At the highest point, we don't have vertical component for velocity. The only component is horizontal. Why? Because the tangent for a parabola at the highest point, this tangent must be horizontal. Any question? Any question? Any question so far? Okay, Mitchell. I will work a little bit as instructor for math. If you have equation 5x squared plus 2x equal 0, can you take x outside this equation? Yeah, x. If you get x outside, the remaining will be 5x plus 2 equal 0. We have two options or two scenarios, because if you have a term time another term equals 0, one of them equals 0. So probably x equals 0, or 5x plus 2, the second term, equals 0. So from the second term, I can say 5x equal -2, or x equal -2 divide 5. So we have two options, x equals 0 or x equal -2 divide 5. This is how to solve this kind of equations. Your equation in example number 1 was -4.905 t squared plus 73.6 t equals 0. So I will take t outside this equation. The remaining will be -4.905 t plus 73.6 equals 0. We have two terms. This term time this term equals 0. So one of them must equal 0. I will assume the first one, t, the first term equals 0, or the second term, -4.905 t plus 73.6 equals 0. Go ahead and solve this one. I believe that t will be the only unknown. It will be positive 73.6 divide 4.905. Wait. 73.6 divide 4.905. It will be positive 15. So we have two options, t equals 0 or t equal 15 as a solution for this equation. We rejected this solution. Doesn't make any sense because we don't have time. No, we should have time for anything to move. So I will reject this solution and I will accept this solution. So the time required will be 15 seconds.